Hey everybody, AI agents are getting good, right? Really good. They're taking autonomous actions. They can inspect your Kubernetes cluster, diagnose problems, create resources, and even clean up after themselves, right? But there's this uncomfortable question that most teams are quietly asking. Do I actually want an AI agent deleting things in my production cluster without asking me first, right? And the answer, it's almost universally is no right now, right? And this is where human in the loop comes in. It's the pattern that lets you give an AI agent real tools, real capabilities, while keeping the human in the decision loop. So for anything that matters. So, and not everything, right? Just maybe the operations where mistakes could ruin your afternoon. So let me set the scene, right? What we're going to do here, we're going to build out a human in the loop using kagent, right? So if I set the scene, you build an AI agent that can manage Kubernetes resources. You give it tools, lists of pods, you apply manifests, delete deployments. It works great in demos, right? Then someone on your team asks, hey, clean up an old staging resource, and it deletes the wrong namespace or misinterprets really scale down the database and sets the replicas to 0, right, to your production Postgres environment or stateful set, right? The issue isn't that the agent is dumb, is that there's no checkpoints between the agent decided to do something and the things that got done. There's no moment where the human could look at the plan and say, wait, no, not that, right? Full autonomous agents are fine, and they're fine and ready for operations, but for anything that changes state, you might need a gate. So this is where human in the loop falls in, right? And it's a single new feature inside of kagent open source, and its design patterns have a few distinct mechanisms, right? You have tool approval, right? The agent decides to call a tool, like deleting a resource. But instead of executing immediately, the system pauses and presents the action to the human. And then user ask, right? Sometimes the agent does not need approval. It needs information. The request is ambiguous. Or there are multiple valid paths and the agent needs you to make a choice. For example, which namespace should I create? Is it this one? What do you want to use, Postgres or MySQL, right? Should I apply this to staging or production, right? The ask user tool lets the agent kind of pause the execution and ask the questions, really interview you and wait for the answer before continuing. And it's not a safety gate, it's a collaboration mechanism itself. And maybe the third would be really a combination of both, right? The real power is when both mechanisms work together. And an agent can do that, right? They can read your cluster freely, no interruptions. They can ask you for clarification when the request is vague. They can show you exactly what it's about to change and wait for your approval. And they can accept your rejections gracefully and try a different approach, right? And really, that's an agent you can kind of actually put in front of a team right now. So when I share my screen, I'm going to jump right into the terminal and we're going to deploy this in our environment. We're going to deploy kagent. So let's open up the terminal here. Let me just clear this. The first thing we're going to do in this build demo is build an environment. So all the information on how to deploy this will be available in the show notes that you could see. But and it makes it very simple for you to kind of build out this environment. So first thing I'm going to do is spin up a kind cluster. I'm going to use kind in this demo. It's quite nice and easy for me to be able to deploy this. Once kind is running, I'm going to install kagent open source. You can go to kagent.dev to check this out. But I'm going to need to install two things. First is the CRD into the platform. And I already have my API key exported. If you don't, you just have to execute this command and export your OpenAI key. Next step is what I'm going to do is install kagent. So I'm going to use Helm to make this. So I'm going to install it in my namespace. I'm going to use the default OpenAI, and here's access to my OpenAI key. This takes about a couple seconds to deploy. But what it's going to deploy is it's going to deploy kagent inside of the kind or the Kubernetes environment for us itself. So just a preference, kagent is an open source project building for AI agents that run natively on Kubernetes, right? And these agents are defined with custom resources, CRDs, right? So tools are served via MCP, right? Model context protocol. Servers and everything else can run inside the cluster itself. So the human in the loop feature for kagent works through two mechanisms like I talked about, right? Both built on underlying infrastructure. There's the required approval field. So when you define an agent, and we'll build this in a second, actually let's just jump into that section itself. So so let's show the YAML file in here so you can see this, right? When you define an agent, so I'm defining an agent in CRDs, right? My custom resource groups. When you define an agent, you list the tools it can use. So I'm listing the tools it can use. For any tool that should require a human approval, you can add requireApproval in here. Very straightforward itself. And that's it. Those two lines add safety guards. And the tool is, and the tools in the required approval must also appear in the tool's names. So pretty simple. So I have it here. I have it here. Very, very easy to deploy. Their CRDs validate that this is that, well, the CRDs validate this at creation time. So you can't kind of accidentally gate the tool that isn't assigned to an agent itself. And then every kagent automatically has access to ask user. So you don't need to configure anything. It's built in. When an agent encounters an ambiguous request, it can call ask user to pause and ask the human for questions, right? Interview the human. And the questions can be free text, right? The user types in the answer, can be single select, right? The user picks from a list of choices. Multi-select, the user picks from multiple choices. The agent gets back structured data, not just really raw strings, which makes it easier to act and answer on, right? So what do we do? Let's go ahead and deploy this. kubectl. Let's go create itself. So the way the mechanism works under the hood is the agent calls a tool that requires confirmation. So via that requireApproval or user or ask user itself. The executor, the request confirmation in the blocks, then an event is generated. And when it's sent in the UI via agent-to-agent protocol, the UI renders the approval control or question. So why don't we do this? Let's turn on kagent UI so we could see this really live in action itself. So what I'm going to do is I'm just going to port forward my environment and I'm going to switch to kagent. Perfect. So here I have kagent deployed. When you first deploy kagent, you'll see it getting started. This allows you to really build agents right away inside the platform. So I'm just going to skip here. By default, there's already a subset of agents already deployed. We deployed this HITL agent, so human in the loop agent right here. So what we're going to do is you can actually edit this and see all the information about this agent. See the name, the type, its declarative, its description, what's the instructions that are written really in markdown language, what model it uses. If I want to do Enable LLM response streaming, I could add that. And the tools that we selected in that YAML are all here. And this could be configured in the UI. We have memory inside the platform, context management, and skills if we need to add. So let's go back to the home, and we're going to click on that agent, and we're going to show this. So we have a list of tools here on the right. And let's test this out, right? We want to see this in action and how you can deploy it. So first, let's do this. Let's list. I'm going to ask you, hey, list me the list, or list all pods in this Kubernetes namespace, right? The agent calls that Kubernetes resource, so get resource. And since the tool is not in that required list, right, it runs immediately. You see the results, there's no interruption. And this is, right in the UI, right? You don't have to click approval every time you ask the agent to do something. Only really destructive operations have those gates that we could apply to. So let's see this further, right? Let's say, hey, let's create. So in this, let's create a config map called test config in the default namespace. With the key message set to hello from kagent, right? So the agent is going to call, we already see it happen so quick. If I make this a little bigger, the agent is going to call Kubernetes apply manifest. And since the tool is in the required approval, right, execution is paused, right? In the UI, we see this like paused, approve, reject. And the tool, the agent wants to call, and what happens is it augments this, and it wants to pass, and the arguments it wants to pass are included in a YAML file itself. So you can review the manifest, it looks okay, it looks correct. We can click on approve, and the agent applies the config map successfully to the actual platform. Pretty cool, right? Now you have this kind of human in the loop. So if we add another scenario, what happens if we want to delete an object, right? We are talking to our agent, all right, this is great, let's delete the config map, test config that we just built in the default namespace. So now let's do this. Let's delete the config map to test out, the kagent, or the agent calls the delete resource, right? Execution is paused itself. And it asks you, hey, the agent receives this, reject message and a reason, right? The request to delete the namespace in the default namespace. This is disruptive operation. I'm going to delete the namespace now, and it's waiting, right? The agent receives this rejection reason, and instead of failing or retrying, it acknowledges your decision, right? And responds, understood. I'll leave the config map place, but let me know if you want to do anything. So let's approve this, right? And perfect, it deleted that resource. And the key detail here is the rejection reason isn't just logged, it's sent back to the LLM as context. So the agent can adapt its behavior based on why you said no to, which is awesome. So last scenario, let's set up a namespace. We want that ask scenario. Agent asks for clarification. So, hey, set up a namespace for my application. Right? The agent doesn't know what to call this namespace. Right? Instead of guessing, it calls that ask user. Right? What should the namespace be called? Right? Hey, could you please provide the name of your the name you want to assign to this namespace? right? Awesome. All right, let's go staging app is what I want to call it. Let's do that. Perfect. So I type it, the agent continues creating that namespace with the specifics, right? With whatever was specified itself. So now we're going to approve this and the namespace is created, right? And this is the difference between agents that guesses wrong and an agent that gets it right. And the cost of asking is just a few seconds. The cost of guessing something wrong is rolling back a mistake, right? So when we're talking and deploying this and trying to figure out design principles, right? There are a few things that K-agent, human in the loop implementations that are kind of worth highlighting, right? Opt in and not opt out. Tools run freely by default, right? You explicitly list which ones need your approval. This means adding a new read-only tool to an agent doesn't require updating any approval configuration. It just works. It's declarative, right? Not procedural. You don't write approval logic in the code. You need a tool. You add a tool name to the YAML list. This keeps agent definition readable, audible. A security person can look at the agent YAML file and immediately see what tools are required for human approval. Rejection is contextual. When you reject a tool, you can provide a reason, right? And the reason is returned back to the LLM as part of the conversation context, which is super important, which means that the agent can learn from your rejection in the current conversation and adjust its approach. And for ask, right? Ask user is always available. You don't need to configure it. It's built in on every agent, and it encourages the agent builder to write system prompts that tell the agent to ask when things are ambiguous rather than assuming itself. So when to use human in the loop, right? Super important. Any operation changes the current state, create, update, delete. Operations that are hard to reverse, deleting PVCs, removing finalizers, right? Multi-step workflows. So where early decisions affect later steps, right? Or any agent that can be used by people who aren't agent authors. So given access to somebody. Places you might want to skip human in the loop. Read-only operations, so listing, describing, reading logs, internal agents for reasoning, tool calls that don't affect external state, or fully automated pipelines where latency matters and rollback is cheap, right? The goal is to make every action require, the goal isn't to make every action require approval. It's to put gates where they matter, right? So human in the loop for K-agent is one piece of the puzzle, right? K-agent supports A2A protocols for agent-to-agent communications, MCP servers for extending agent capabilities with custom tools, memory for agents to learn from past interactions, skills for packaging reusable and agent behavior itself. A lot of cool stuff you can do with K-agent. And this is just one of the features that is introduced in really the new version itself. So make sure that when, what I'm going to do is add all the notes, the keynotes itself. But why I think it matters having a human in the loop also gives you at the end three things. Transparency. You can see what exactly agent is doing and why, because all this stuff is sent to your logs. You log all this data. Control, nothing happens without your approval. And speed, the agent does the diagnosis and proposes the fix in seconds, not hours of manual debugging. And this is really how you get these production grade AI agents to look like users actually doing something, to making it used, right? So once again, kagent.dev is the website. Show notes posted below. Kagent is an open source platform, and it's donated to the CNCF Sandbox projects. Try it out, start the repo, and start building some agents. Oh, and links in the description.